Part two. Part two, we're now going to measure speed V2 experiment using momentum and energy conservation. So how do we do this? So what we're doing here is that we're effectively doing the same experiment all over again. So from part one, we shot a steel ball with speed V1 experiment plus or minus sigma 1. So in part two, we don't really pay attention to that. We just know that the ball is already in motion, right? It's already in motion, and it has this speed right here. But in part two, what we're going to be different is that we imagine that we have an inelastic, and I should be careful and say completely inelastic collision between the ball and a pendulum catcher. So in other words, I have my ball coming in, but now I don't call it V1, I call it V2. So I see my ball coming in, and now I have a pendulum catcher. At the moment, I'm only going to draw the catcher by itself like this. So clearly, here is the ball, and then this guy is the catcher. So when I look at this thing, I'm going to treat this as my system. So if I'm looking at my system, we know that this is what's going to happen beforehand. And then after, I have a collision. And so now I have my catcher. And we assume again that the collision is instantaneous. But now the combo of the two is now leaving at some speed that I call V pendulum. And this is what's happening after the collision. Now, can we use momentum in this situation? So we know that it's an instantaneous collision. Of course it's not, but that's our assumption. And from here, there are no external impulses acting on the system. Now, that might be a little bit of a white lie, but I'll talk about that in a moment. But we're going to say that to a pretty good degree, I'm going to say that the external impulse is zero. And as a consequence of this, we can then use conservation of momentum. So if I can use conservation of momentum, then I'm going to start with a bar diagram to see the overall picture. And what I'm seeing here is that I have a pendulum, I have the ball coming in. And it's coming in with this momentum P2, which is, of course, the mass of the ball times the velocity 2. We know that the pendulum starts off at rest so that the momentum of the pendulum initially is 0. So then this is my line for my total momentum line. And I can't create or destroy momentum. So then afterwards, I have a combo of the two, which now move off as the momentum of the pendulum. And what you're going to see here is that so if I look at the momentum of the ball, we could see that it's associated with the velocity 2. And if I look at the pendulum of the system, remember, this is going to be the pendulum of the ball plus the mass of the ball and the mass of the pendulum. And it's going to move off with some speed that I call v pendulum. So right away, we see here that this picture tells us that that momentum conservation connects V2 to V pendulum. In other words, if we measure the speed, we immediately know V2. So we're not measuring V2, we're going to measure V pendulum. So now that's said here, I could now go in what happens after the collision. So now, after the collision, the pendulum ball system moves upwards. Right? When I say moves, in other words, it swings up. So if I look at my picture, then this is what I have here. I have my pendulum ball system. And what's connected here is that I have these arms to this system right here. And here's where the system, you can actually get an external force here. So one can get F external right here, and it could actually change the momentum. But lucky for us, we're not changing momentum. We've already done with momentum. So now what we're focused on is we're focused on using this information that now moves at V pendulum. And again, I should have done this a little bit more clear, and I need to move this down a little bit. And this is what happens before. And so when I look at this thing, what we're going to do here is that we're going to say, this is our system here. And when I look at the system, is there any external works that are being done? And we're going to find out that there is a tiny bit of air drag. And there will be a tiny bit of gravity, but for the most part, you're going to find that by conservation of energy, the work of gravity will allow us to make this calculation very nicely. The friction is something that we're going to ignore in this lab. So now, here's what goes up? What goes up is the center of mass. So where is the center of mass? Well, it turns out that it's not at the center. So I'm going to say that this is not the center of mass for this system. You must determine that yourself. So you're going to see that you're going to have to find what that center of mass is looking like. And then after this collision, there's a way using conservation of energy of how to get the details on that V pendulum. And so what happens here is that this guy is then going to swing upwards. And as it swings upwards, what we're paying attention to is the center of mass of the mass ball pendulum. And again, this is not the center of mass, but we're using this as a discussion point. And what you're finding here is that if I now look at the center of mass point here, this is the height that you want to pay attention to. This is the height change of the center of mass point. And that's what you want to measure right there. So up here, we had momentum conservation that connects V2 to V pendulum. In a very analogous way, we have that energy conservation connects the pendulum to the height change of the center of mass point. So we then now have a flow chart. Now we have a flow chart to measure V2 experiment plus or minus sigma 2. We start off by measuring the center of mass height change. From that center of mass height change, we can connect this using energy conservation. We could then get the velocity of the pendulum. From this velocity of the pendulum, I could now connect this using momentum to get the velocity v2. So now what you want to do here in this last part of the lab here is that you want to set up the pendulum system and make height measurements. So in this case here, you're going to have 1, 2, you're going to have 10 measurements, and then you're going to have a height in meters. But note, I now have my height, and then from my height, I'm going to use energy to then set up a table to get the velocity of the pendulum. And from the velocity of the pendulum, I'm then going to get the speed of the ball after that. So if I set up my table, it's going to look something like this here. And so what you're seeing here is that now we want the average of V2. We want sigma, the standard deviation. Then we want our confidence interval, which will be V2 minus sigma 2, V2 plus sigma 2. So for today, the only thing that you have to do here is that you have to make 10 height measurements. That's what you got to do. And again, like we said earlier, our goal is to compare V1 experiment versus V2 experiment and see if they overlap. If they overlap, they're consistent. And remember, in this guy here, this is the one just by the launcher, and this guy is the one that uses a combination of momentum and energy.